Hi there and welcome to algorithms. Well, what kind of algorithms will you need to deal with, especially in the exam? You'll need to look at searching and sorting algorithms. These are the most common algorithms to encounter in the exams and to figure out. Algorithms, of course, is a means of showing a sequence, and searching something happens sequentially. Sorting something also happens sequentially. Well, let's look at our first example then. Let's have a look at technique number 1, linear searches. A linear search is simply a scan. For example, here we have an array of student names and we need to look for Harry. So what the algorithm does is it starts at the beginning and scans the entire list looking for Harry. When there's a match, we presume the algorithm returns a match. So find Harry. Compare each item in the list with Harry. It's a comparing algorithm. Now, as soon as you have to go through a list, you must think loop. In other words, repetitive. It is iterative, meaning it will repeat and loop the program, the algorithm, until it finds what you're looking for. So it's comparing, which is also going to bring to mind Boolean. So the algorithm looks at each string and does it match Harry, and it will be no, no, no until it hits a yes, and when it hits a yes, the program can terminate and it can return Harry, found, and then preferably give the index number where Harry can be found, so 0, 1, 2, 3. I'm just using 0 as the starting position of all my arrays. So index 0, no, it wasn't found. Index number 1, no, it wasn't found. Index number 2, no, Harry wasn't found, but at index 3, Harry was found. So I return Harry found, index equals 3. This is so that I can search through the array and know where Harry is exactly. What kind of algorithm is this? Well, if it repeats, the program will contain a loop. So it will repeat until found. And we've got two simple steps in our algorithm. Get the first element from the array. If it's not found, just repeat this until it is found. There's a couple of sub-elements to this algorithm that you can find in your textbook on textbook page 91, I believe, somewhere around there. But those are the two main elements of our algorithm. Now, pseudocode. Please remember that pseudocode, there's no real rule for pseudocode. Some of the pseudocode in the textbook, it amazes me how it was written. It seems incredibly confusing. When I look at other examples of pseudocode, I think, wow, how incredibly clear. What will you be presented with in the exam? Well, hopefully a very clear piece of pseudocode that you've got to figure out what it does. This is my bit of pseudocode. I'm saying my array is called our students, and my string is indexed 0 to maximum, or 0 to the last number, or 0 beyond the last index number, -1 if you like. The sort for word is called this element. So I'm looking for this element, and this element is Harry. So I'm going to repeat the following steps. If my student array list, which I'll start at the 0, I'll start at the first, equals the element I'm looking for, my variable is called this element, then simply say found is true. Or found will be false, but until the found is true, or I've exhausted the list, continue repeating, otherwise end. I suppose I should say end at the end there of my pseudocode, just to make sure that the program, the algorithm does exit. Right, let's look at the next thing. Bubblesort. Now, we've done a search. This is a sort. It is a slow method of sort, but it is a common method of sort. This simply compares each item in the array with the one next to it and swaps it if it is not in order. So if you've got numbers 1, 5, 7, 2, we want the numerical array to be in ascending order. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and all it does is compare the numbers with each other and moves down the list. That's Bubblesort. So it is a sorting algorithm and can be used to alphabetically sort, numerically sort, or sort according to any predefined rule that we've set up. So let's sort by first letter and second letter, and so on and so forth. And that's Bubblesort.